Let's try another example. Once again, let's ask ourselves two questions. Is there a number that could divide all the coefficients? And is there a power of x that they all have in common? We might notice that that x to the third term in the front has no coefficient, so we'll write 1. We now also have negative 12 and negative 13, and so there isn't really any number that can divide all of those coefficients. However, they do all share a power of x. We have x to the third, x squared, and x to the first. Again, writing the invisible 1. So we'll write there is a power of x we could divide by. And it's x to the first. So we'll divide all terms by that to begin with. For our first term, we'll have x to the third divided by x to the first. And remember, anytime we divide powers of x, we are subtracting the exponents. We'll take that new exponent as 3 minus 1. Therefore, we will now have 1x squared. For our second term, we will have second power minus first power. This will give us negative 12x. And for our third term, x to the first over another x to the first cancels out the x's and gives us no power. This will give us negative 13. And remember that we will write the x we divided by on the outside. Now that we're here, when we have a trinomial in our parentheses, there's another question we can ask ourselves. Is there any way we could simplify that trinomial further without using any of the techniques we've seen previously? So now we have a monomial times a trinomial. And we will label the terms for that trinomial A, B, and C. Term A will be the second power term. Term B will be the middle term, that is first power x term, and C will be the third term that has no x, or the constant term. When you have a trinomial, it is possible to simplify further sometimes. But not all the time. The cases that we're looking for are a specific case where there are two numbers that multiply to make term C, but add together to make term B. So we could ask ourselves, what two numbers could multiply together to make negative 13? Now, our C value is negative 13. There are two different ways we could make negative 13. We could say negative 13 times 1, or positive 13 times negative 1. Multiplying either of those would still give us negative 13. So we know that we're going to have to use one of those combinations. But now let's try adding them together and seeing if we get negative 12. The first option, if we take negative 13 plus 1, this does indeed give us negative 12, and that's a match. If we tried it with 13 minus 1, that's for the second option, this would give us positive 12, which is the wrong sign even though it is the right number. We want to match that negative 12 inside, and so this positive 12 again will not get us there. We must use this option. Now that we know negative 13 and positive 1 will satisfy our criteria, let's now split this trinomial into two binomials. Those two binomials will look like this. We'll have x minus 13 for the first one, because our first number was negative 13, and then x plus 1 for the second one. So when we write our answer, we will still have the first x on the outside, that monomial that we have not touched, and now we'll have two parentheses instead of one. We'll have x minus 13 in our first parentheses and x plus 1 in our second parentheses. Now that all of our x's are first power there is no way for us to factor any further. And so the negative 13 and the positive 1 that we have will go in the parentheses, added and subtracted to x. This will be as far as we can go.